some of you might be something new. For some, it's going to be more or less the same with a couple of updates here and there. I guess the first thing will be to know a bit about what's our environment, what kind of systems we have, what kind of communities we have, and to understand a little bit better what are our requirements. So what we have, or in the systems where we are deploying EasyBuild, are this at the moment. We have Eureka. We have Eureka Booster, which is a module of KNL nodes attached to Eureka, and it's intended to be used as something that works together with Eureka, something that you can use on the same job. You can use both kind of nodes at the same time. And so it's a kind of reinforcement, so to say, to Eureka. And I'll say a couple of things about it after that, after describing what's Eureka. And then we have a couple of test systems, test clusters, drums, and Europa 3. Europa 3 is a test cluster that we have for our own staff to play around with some things internally. Drums is a system that is dedicated to a specific community on neuroscience, I believe. And we're going to have soon Jewels. Jewels is the new system we're going to deploy. That's going to be ready hopefully by the end of April. That's going to replace Queen, which was our main system until now. And and I'll say a couple of things about it after in 5 minutes. So the system characteristics of Eureka are more or less this. It's a standard Intel cluster. There's nothing really particular about it. It has roughly 1800 compute nodes. It has a little bit more than 2 petaflops in total, including GPUs. There are some nodes with GPUs, even though they are not the main focus, so to say. Most of our users and most of our nodes are just CPU nodes. And then, we have a few visualization nodes, a few logging nodes, and that's more or less this. The user community we have is quite diverse. We have roughly 1,000 users, more or less. Those were actually numbers from last year. So this year it's going to be a bit more. I'm not sure exactly how much more, but it's roughly 1,000 users. And roughly 200 projects from all kind of sciences. So that kind of makes the environment a bit complicated, because if you take a guess on the user requirements, so it's something like they want it all and they want it now. And that's, this is the first time I present that, and I'm getting tired of this joke. I promise I will never make it again. So they want Intel compilers, they want new compilers, they want PGI compilers, they want diverse MPIs. We have PowerStation MPI. That's something that we use, that is developed in a consortium together with a company called Partech. They need Intel MPI. They want CUDA for the GPU nodes. They want, of course, CUDA-aware MPI. And tons of libraries and compatibility between all the components. So that kind of makes it a bit messy and complicated to manage. And to make it funnier, or better, now we have the booster. And that's something that we deployed roughly, I think 4 months ago. We started roughly 3-4 months ago. And so if you put it together with Eureka, you have a system that is roughly 5 petaflops. That poses some challenges, because you have these 2 very different set of nodes that you want to use together. And enabling that is not trivial. Now it's, number 29 on the top 500 list. So it's actually possible, for those of you that might be skeptical, to have, if it's possible to have working together Haswell and KNL on the same job and have something reasonable. It is in principle possible, even though it's not trivial. And it's roughly 1,600 compute nodes. It's omnipath, it's not InfiniBand, so we have a set of nodes that bridge these 2 networks, InfiniBand and omnipath. And and as I was saying, it needs to play nicely with Eureka. So that, So that adds another set of requirements. The jobs have to be able to use both parts of the system simultaneously. You should be able to cross-compile when possible, but many times it's not possible, especially if you have code that uses auto tools for building. Because there's configure, and it generates all these binaries. These small checks. These small checks, if you compile them with AVX 512, well, they are not going to work if you compile on the login nodes. So cross-compiling it's possible, but not always. And the software, in principle, it should be kind of a mirror between what you have on the cluster, what you have in Eureka, and what you have on the booster. And soon we're going to have UWLs, and that seal is me, and that thing there, that polar bear, is UWLs, and I feel that it's coming. It's going to buy me soon. So that's another system that we'll have to manage with EasyBuild. It's 2,500 compute nodes, Skylake, and other than that, it's similar, so to say, to Eureka in the sense that it's an Intel cluster with InfiniBand and a few GPU nodes, but it's something that it's a bit more modern. What it's going to be different is the set of software requirements, because the user community is going to be something different. That's going to be a praise machine that's replacing uQueen. So the users that were using uQueen until now, they're going to start using UWLs, and probably other users that were using other praise systems, they will come and use UWLs as well. So the set of software, in principle, it can and it will be different. How different, I do not know. So hopefully we'll find out soon. So to try to make things easier to manage this holy mess of environmental requirements, we went for a hierarchy of models. So what you have, that is something different from the default model naming scheme of EasyBuild. So there's a hierarchy where you present first, essentially you present first just the compilers, and when you load the compiler, the model path gets extended. That shows the models that were compiled with that compiler, and that shows the MPI runtimes that are available for that particular compiler. And once you load the MPI, well, you see the models compiled with that particular combination of compiler and MPI. So what that means is that it's more or less intuitive, except for the users that are like really not HPC, they are not really into HPC. They just want to use whatever software. You know, like, why should I use this compiler? Why should I use this other compiler? So for those, we have a set of default modules that load the recommended modules of the recommended compiler and MPI, and that kind of users can use that as let's say as a shortcut to don't be bothered with, well, should I use this compiler, this other compiler? What is the difference, etc. So yeah, and as a result, all the software you can see in a given moment, it's all compatible. That's probably the main reason for using a hierarchy. And we have, if you take a look at the repo at our repo in EasyBuilders, you will see that our model naming scheme is slightly different for the default hierarchical model naming scheme that ships with EasyBuild. So we tune it a little bit to make the name of the models, make it a little bit more user-friendly. So instead of having ICC Ford, you have Intel, and that sort of thing. We use Elmod as models tool, essentially because I think there's no other option. If you have a hierarchy of models, you need to have Elmod. You need something that has a spider and that can look into the cache to be able to find the software you're looking for. So that's the main reason, but we are quite happy with it. So even besides that, I wouldn't go for another one, at least right now. We make sure that that we can keep a consistent environment using families. So for the compilers, we use the family compiler, for MPI, family MPI. So what that does is swapping the models, even if they don't have the same name, just models that belong to the same family, they are swapped. So Elmod can enable and disable models as it's needed. And there's also another set of interesting features. It has a good support for hidden models, which we use extensively. And it has properties, so we can, for instance, show which model, if a particular software, and you're taking a look at the Haswell stack, and you can see we don't have that implemented, but it's planned. You could see via properties if that particular software is also available on the booster. It has hooks. Well, it has a number of features that I think most people are familiar with them, according to the survey the show this morning. So I'm not gonna spend more time here. This is what the user sees as he or she logs into the system. There's a set of core packages, and this is a small trick we did on Elmot to replace instead of showing the model path, we use labels to show what is each thing. So we have core packages. These core packages include the stuff that is installed in Damian and the stuff that is installed on GCC core. What difference that we made from last year is that now we are loading GCC core by default, and we are grouping Damian and GCC core. We are grouping it in core packages. The reason for that is that we have a lot of packages installed on GCC core, like CMake, and it's kind of stupid to force a user to load GCC core to use CMake. So we just load GCC core by default, and you have all these tools that are expected to be in the system, so you have them directly available. Then there's a set of compilers. Then there's the recommended defaults, and normally we have defaults for CPU and defaults for GPU. The reason why you don't see defaults for GPU here is because it used to be Intel plus Envapage. Now with the latest Envapage release that has support for CUDA 9, turns out that they didn't release a version with Intel compilers yet. Or recommended toolchain on that particular case, it doesn't exist at the moment. And that's a reason also for us to think seriously into swapping or CUDA-aware toolchains, swapping from Envapage into OpenMPI, because it makes things just way easier. We don't have to be waiting for anybody else. There's another reason for that as well, and we are having a pushing community of deep learning, and most of the software used in deep learning and related environments relies on OpenMPI, not on Envapage. So at the end, my gut feeling is we are going to end up swapping from Envapage to OpenMPI, but it's not decided at all at the moment. What else? Then you have the architecture models, and those are the models that swap the whole model tree from what you see or what you can use on Eureka or what you can use on the booster. This does two things. It swaps the whole tree, but it also swaps the Elmot cache. So you cannot, in principle, you cannot check from one place, or if you have one architecture loaded, you cannot check what is installed on the other one. You have to load it, so the cache, the Elmot cache gets swapped, and the user can check it. The reason for doing that is that if you don't do that, then at the end you will have a humongous cache, and then it's going to be confusing for most users, because most users won't be using both at the same time. So you just load what you need and look the architecture you need and try to find the software there. I think there's a question. The microphone.
What's this S
behind? That's a sticky model. That's a property on Elmot. So properties in Elmot shows us letters close to the model. And in this particular case, the S means sticky. And so when you do a model purge, that model doesn't get loaded unless you explicitly force it. And there are some models that are kind of delicate. So if you by mistake unload it, you can easily have a broken environment. So those are sticky. And it's the same for stages. I said something before about the stages, and there's something later as well, but I can just say what a stage is. We deploy a completely new software stack twice a year, right before new projects come into the system. So to kind of push new users to use the most modern environment that is possible at that moment. And that's kind of like, each stage is kind of a frozen snapshot of the most recent software. And when something is installed there, in principle, it's never removed unless there's a bug. And we try to be clean when it comes to having different versions of software and that kind of thing. So we don't have 3, 4, 5 different versions of the same package. But there are users that throughout their project life, they want to use always the same compiler, the same stack. So we cannot just remove everything. So we kind of stage our software. And so if you started working on our system last year in February, you still can use the software that was available there. You just have to load this at the proper stage, and it's going to be everything as it was when you started using the system. And then there's development modules that this essentially just sets up the environment for us to install software on the system. It's essentially loading the EasyBuild configuration, and that for that it has to load some of the variables that is defined on the stages. These two set of modules, the stages and the development modules, those are not visible to users by default. They can see the other stages, they can see them when they add that model path to their environment, and we have it on our documentation how to do it, but by default they don't see it. So they just see what looks more, well, just the compilers, architectures, defaults, and the core packages, and all properly. We try to do it properly structured, so it's as clear as possible. So what is the current state at the moment? We have this hierarchy of tool chains. We have dummy. We have CUDA installing dummy as a dependency. We don't have CUDA as a tool chain. We have 2 sets of GCC core. The reason for that is, as somebody said in the morning, is that, well, CUDA doesn't support the latest GCC, neither does Intel. So Intel always needs a GCC underneath. It doesn't support GCC 7. So we went for 5 and 7. 7 is the most recent, 7.2. And 5, we felt that it was something that was properly tested. We could switch to 6, but GCC 6 didn't really give anything that was useful for us. So we just stick to something that was a bit more proven to try to keep the number of bugs and issues to the minimum. And we initially had Intel 2018, Intel 2017 to be used on the GCC tool chains, GCC 5 and PGI 17.9, and GCC 7. Somebody said on the mailing list or in one of the telcos of EasyBuild, I think it was Hake, that this one, 2018.0, was creating issues when compiling software with AVX 512. I said before that the software we need on the booster kind of should mirror more or less, or should be a subset or a mirroring subset of what we have on Eureka. So that's the reason why we had to create another set of tool chains for this, because on the booster we have KNL, on KNL we have AVX 512, so we couldn't use 2018.0. We had to change to another one, and that forces us to install another set of tool chains, which is a bit of a waste, but there's I don't see any elegant way around it. So yeah. And then we have, as I said, we have PowerStation, we have a multi-threaded version of PowerStation, we have Intel MPI, and we have MVAPage. And so you have to combine all those with the compilers, and in the end you end up with this tree. Well, which is, if you start considering all the software that is installed on each level, at the end it's not trivial. So well, this is what I was saying before. The initial user view, they see the compilers, the binary tools, so stuff that is installed in dummy, package build with GCC core, which is preloaded. It's important also, if you preload GCC core, to preload vin-utils to make sure that it's using the same version of vin-utils that you were using when building the software, and not let the user have GCC core together with the vin-utils from the system. That can lead to issues. And yeah, and I think this I explained it before, so I can just skip it. Yeah. In the booster, this is the toolchain hierarchy we have. We don't have any of the GPU toolchains, obviously, because we don't have any GPUs on KNLs. And we don't have this version of the Intel compiler because it's bogus when you compile with AVX 512. So we went directly for this, and we have also GCC 7. I think, yeah, later I have something else related to that. I was mentioning before as well that that we use extensively hidden models. There's roughly 200 hidden models, or there was roughly 200 hidden models in stages where you have 2 GCC cores. You can get to 400. That was before we were using the bundle for X11, so now it might be a little bit less, but it's still a very significant number of hidden models. The reason for that is that in many cases you don't really want to load these models to see them. You need them because they are dependencies of important models, but you don't really need to explicitly load, I don't know, dbus. So all we have a list of software that is hidden, and that is set on this developers model that I was showing before. Yep. What else? Regarding bundling, we also use bundling extensively, and we do it differently from what EasyBuild does by default. We have Python, and we have Python at the GCC core level, where we have all, well, not all, but we have up to 80 extensions at the moment, and that includes part of what was SciPy stack. So what we had before, for instance, was IPython. We had it on the model that it's called SciPy stack, just because the SciPy stack includes IPython. But that's kind of stupid in a way that, well, you might want just to use IPython because it's convenient. So just put it on the default Python model. It works, and you don't have to load compiler and MPI to be able to load the SciPy stack model, because the SciPy stack model, it includes NumPy. NumPy is linked with MKL, and MKL is at the top level of the hierarchy. So that's why SciPy stack is at the top level. But that's not. We should put, I think, or from our perspective, we should put as much as possible underneath on the default Python model, because from the functional point of view, there's a lot of packages that you really don't get any performance benefit from compiling it with Intel or with whatever. So yeah. We have R, and we essentially take the R package that is upstream, and we add a bunch of packages that users requested. So it's just, I don't know, 10, 15 packages that we append at the end of the extension list. And yeah, and then Perl, just the default Perl. I don't think we add anything in particular there. And X11. Before we had our custom solution for X11. The model was called X over G, and that's something that Alan, a colleague of mine, prepared. That was leveraging JSC to build the whole X over G stack. It was 200 and something extensions. But in most cases, it wasn't really needed to have something, to have all these extensions, and there was kind of duplicated effort. So we just changed back to X11, which was kind of implemented, and they had Alan kind of had this kind of race at that moment. So I felt kind of guilty to go to X11 and use kind of solution. We felt like stabbing my colleague on the back, but it's just more maintainable. So. Because he does it, so I don't have to care about it. So yeah. So to enable the KNL stack, yeah, I mentioned that before. You load the KNL architecture or the Haswell architecture, depending on what you had loaded previously, and it solves the whole model tree, solves the cache. And one thing, if you want to enable cross-compiling, is that you have to be careful on how you compile stuff on GCC core. Because if you're not careful with it, you are going to compile it with the optimizations or with the instruction set for KNL. And then you're going to do CMake, and it's going to tell you illegal instruction. And it's going to be like, that's stupid. So you have to be careful with things compile on GCC core to make them compatible with on both sides of the system. So yeah. And the way we show that as well is that, well, on the login nodes, we show, or we mount both stacks, and both are available. On the compute nodes of Eureka, of the cluster, we have just the Haswell stack, and on the booster nodes, we have just the KNL stack. So yeah. Then, well, the stages, I mentioned them before. So, yeah, I think there's nothing else new that I mentioned before. Well, yeah, the golden repo. When something is tested, and by tested I mean that we check the EC config, we check that everything makes sense, that it follows certain standards, that the versions of dependencies are correct, that there's no hard-coded paths, et cetera, we add that to our golden repo. We don't do a full test of all the software we install. I ask my colleagues, well, I deploy the whole stack, please test it. Some people test the things they are responsible for, the things they are experts on. Some people don't, so sometimes we might have, in certain cases, but now it's not frequent, but we might have cases where, well, something is not working and it's being installed for 1 month, just because nobody tested it before. Yeah, so we put that in our golden repo, which is public, by the way, and we have an overlay for the booster. So for each stage, we have our golden repo. The golden repo, the way we have it structured is, well, alphabetically, and then every software going into its letter. And then we have in there a KNL overlay, and we prepare the KNL overlay on the robot path. So when you install something for a KNL, for the booster, you check first if there's a package available for the booster, because there are in some cases, in few, but in some cases there are small differences. For instance, if you install Scalaska, you might have as a dependency Cube. Cube is the tool for visualizing traces or profiles from Scalaska, and that requires the GUI. But you really don't want to have a GUI on KNL. It's pointless. You will use the login nodes or compute node for that. So the set of EC configs is slightly different to disable this GUI part. There's another component, for instance, of Power Station MPI that is, well, the very low level communication layer, and that's also different between the booster and the cluster, because one has OmniPath, the other one has InfiniBand, so you have to do a slightly different build. And I think there was a question there. Okay. Yeah, 5 minutes is enough. Yeah, and there's development stages where everyone on the software team is allowed to install software, but in production, just the software manager, in this case me, is allowed to install things. The reason for that is that at the moment it's just me, the one that hasn't complete overview of what is installed and how, which versions, etc. So if you let people install things in production and they are not careful, you are going to end up with 1,000 different versions, even minor differences of the same package. So just to ensure that things are of proper quality and consistent. And we switch stages between in maintenance windows. So we shut down the system, or well, we don't shut it down. We just kick the users out. We switch the stage, and then when they're logging, they see the new stage. We have our own repo, as I said. All our EC configs, all of them are different from the ones that are upstream, but in most cases the differences are minimal. It's just a version, a minor version bump. Is maybe the site contacts that we add or contact by default, and or we might move things on the hierarchy. EasyBuild in most cases puts everything up top level. We try to put everything as low as possible to avoid replication. Yeah. So and that's the address of our repo. So if you want to check it, you can just go there and you'll see what we have. And future work, what to change. These things on top, they've been there for a long time already. I showed them last year, still no progress. It's kind of a shame, but well, it's what it is. So this, what these two things essentially mean is that one thing was what Kenneth was mentioning in the morning about being able to go upstream, to go to the website of whatever software package and check if there's a new version, and kind of do that automatically instead of having to go you manually change your EC configs, which is kind of it's a tedious work that could be in principle automated. It could be, I'm not sure it can be in real life, but that's something that we should explore. Also, automatic upgrades of dependency versions, and that's related also with a point that popped out on the survey that people want to make the versions or the dependency, the check for versions on dependencies a bit more flexible. So that's something I would like to do as well. So you have, I don't know, you have CMake 293 installed, and the EC config you want to install, it has 292. Well, just pick the one that is already installed. You don't need to install a new one that essentially won't add anything. 5 EC configs, but that's a long discuss and a long well, something that to be done in long term, very long term. And things that are probably more immediate is being able to specify op arch specifically for GCC core and not just for GCC. At the moment it works now. It's on by compiler, not by toolchain. But as I said before, for GCC core, especially if you want to share that base layer among different systems, you don't want to compile it for a specific one. You want to have something more generic. So that's something that I think it might make sense. And
that's not there yet?
No. What is now is by compiler. You can say GCC, whatever, and Intel, whatever.
I have it. It's a one-line change.
Yeah, we were talking about it on the last telco, I think. So we have to see these days how it's done and how you did it, and maybe try to push it upstream. Okay, perfect. So, is it in the morning or?
Yeah.
Okay, perfect. And I think you also mentioned on the last telco the next one that you can also install GCC core on different paths that the rest of the software have a different prefix. Or
we do the same as you would at the core level, same as you guys do.
Okay.
That's part of that's just in the custom hierarchy.
Mm-hmm. All right. Because one thing that we don't do at the moment is we just have a prefix and we put the stuff in there, and to share GCC core, to share the base layer among different systems. Well, it might make sense to install it in a different place to allow that.